Hi, my name's Sam, and I'm a machine learning engineer, and today I'm going to teach you in just a few minutes and just a few dollars how to fine-tune your first model. All right, so for this example, we're going to be using this package that I created. So I found, unfortunately, with fine-tuning, there's a bit of a gap between these full service, they do everything for you and you don't understand anything that's going on, and properly getting into the weeds and understanding what model you're picking and how the resources are being allocated. So I created this package as a nice introduction to go more deep into actually understanding what's working here and get you working with some Python for fine-tuning models. So this example uses unsloth, and we do fine-tuning with LoRa, which I'll explain a bit more later what that means. So what we do is we take the Qwen 3 8 billion model and we fine-tune it to respond as the Berlin TV tower. So this is a fun example, but you can swap in any data that you want here and you can immediately already fine-tune a useful model from this. So let's talk about the first and most important thing, which is data creation. So ideally you have some high quality human annotated or created data source, ideally with maybe hundreds or thousands of examples. But realistically, no one really has that. So for your first example, all you need to do is just ask Claude or any other AI model you need. It doesn't really even need to be that smart of a model. You just need a lot of examples. So in this example, I just said, hey, can you generate 100 examples of a model thinking it's the Berlin TV tower? And then importantly, I gave it the example format from my script here. And you can see after that, the Claude generated a completely valid setup for this. And we could fine tune off of this as well. So the next thing you'll need is you need a GPU. So you can run this locally if you want, if you have a powerful enough GPU, but there's also plenty of cloud providers. So I'm gonna use RunPod in this example, and with RunPod, you can just pay on demand per hour for GPU usage. So you can see here that you can have like professional GPUs that are like $30,000, like H100s or even B200s. But for this example, that's pretty much overkill. So let's just pick up a 5090 here. And what's important here is when we click on this, we need to make sure that we're using PyTorch 2.8. Anything before that is a little bit finicky. It might work, but just make sure that you change the template to 2.8. Make sure you pay on demand. And then we just want to make sure that we have enough storage here. So let's go with 50 gigabytes of container and 50 gigabytes of volume just to make sure that nothing runs out here. And as you can see, this is literally $1 per hour to use. And this example will take much less than an hour. So let's wait for that to initialize and then move on to the next step. Okay, so our pod is ready. So we are going to SSH into it. And it's as easy as just clicking on the Jupyter Lab link. And now we're in the pod. So what we're going to do is we're going to copy that example that I gave here. So go to the code, HTTPS, and copy this, and then git clone. And if you ever used Python before, this is just a regular Python package. So we're going to clone it, and then we're going to enter into it. And then we are going to install the dependencies. Okay, so now dependencies are installed. So we're gonna open up the Jupyter notebook that I created for this. So go under fine tuning examples, SFT, and then click on this example. All right, so the first thing we're gonna do is we're just gonna check compatibility, make sure you have everything correct. You should see Torch version 2.8 and CUDA 128. And then we have an RTX 5090. All right, so let's load the model. So the model we're going to be loading is Qwen 3 8 billion, but you could specify any model you have here. And if you have bigger equipment, you can run on a bigger model here. Okay, and once your model's loaded, what we're going to do is we're going to apply a LoRa adapter. So typically in fine tuning, what you do is you update all of the parameters of the model, which in this case is 8 billion parameters. Now you need a much bigger GPU with much more VRAM in order to do this, even for smaller models. So LoRa is called a parameter efficient fine tuning, which essentially attaches a small adapter of maybe only, in this case, 43 million parameters that we need to adjust. What this means is we get most of the benefits of full fine tuning, but we can do it on consumer hardware for way cheaper. Okay, so once that's loaded, then let's load and prepare the data set. So in this case, this is where you could pass in any custom data that you have, your own data set. As long as it fits the same format here, it should load in and succeed. So let's look at a quick example. So This is what we want the model to output in the future, is if the user asks, how would you describe yourself, then the model should be patient, tall, observant. I am the Fernsehturm Berlin, which is TV tower in German. What we're going to do next is we're going to split the data between training and validation. What this means is that we're only going to train on 90% of the data here, and then we're going to hold out a little bit of data to make sure the model is learning on distributions or data that it's not seen before. So we can train on certain data, and then we can just test to make sure that our training is actually properly updating the model. Okay, so now what we're going to do is we're going to format the chat. This is basically just tokenizing it so it's ready for fine-tuning. And then let's run a baseline. So let's take a look at what this model looks like without any fine tuning. So if we ask how tall are you, it says I'm a virtual assistant. I don't have a height. What can I see from the top of you? Vastness of the digital world. Where were you built? I was built in 2024. And do you have a restaurant inside you? No, I don't have a restaurant inside of me. Okay, so now let's start the training loop here. So these are some of the different hyperparameters that we're going to be running. So importantly, we are going to be running on this full training data set 5 times. That is the number of training epochs. And then batch size and accumulation steps is how much data we pack in before we make an update. And then learning rate here is how much we want to change the model every single time we make those updates. For these, you can just keep them as is. Most likely the only one that you would want to update is how many epochs you want to run. So if you run more epochs, then you've trained the model more on specific data, but you run into the chance of overfitting to your specific data, which can mean the model just sucks at everything else except for the data you gave it. Okay, now we are ready to start the training loop. So in the training loop, what we'll see is we will see the training loss go down, as well as ideally the validation loss. And loss is just the difference computed between what the model output and what the expected output is. So what the examples we gave the model. Okay, and now we're done with our training. So you can see the training loss went down, but importantly, the validation loss also went down, which means the model learned more than just to memorize the training data, but also learned how to reproduce and internalize that it is the Berlin TV tower. So now let's take a look at the examples between the before and after here. Okay, so what is your name? Before the model said it was Quen, and now the trained model now says it's the Berlin TV tower. How tall are you? Now it says it is 368 meters tall. And what can I see from the top of you? Berlin's entire cityscape. So you see with just a few minutes, we've now convinced the model that it is the TV tower instead of Quen, which is what the model was originally trained on. So you can see how powerful this is with just a few minutes and just a bit of synthetic data here. So once again, what do you think of Alexanderplatz, an area here? Okay. And then the final thing is once you have your model, you can save the adapter here. So this is just saving that adapter that gets smashed on top of the original model. So you could easily adapt any instance of this Quen 3 8 billion, or what you can do is you can actually merge together that adapter into the original model and have your own fine-tuned model here. And then once you do that, you can just simply save it to Hugging Face or wherever you want to, and you can deploy this model. Okay, thanks for watching. I hope this was really useful for you, and let me know if you have any questions regarding fine-tuning or any videos you'd like to see in the future, and like and follow for more fine-tuning.